Okay, now this is question number 3 of the same paper. Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 330 meters. The probability that Kayla will achieve a success on any throw is 0.25. So the probability of success is given as 0.25. Find the probability that Kayla takes more than 6 throws. So we have to find the probability which is more than 6 to achieve a success. Now remember, there are no number of events given over here. It just says find the probability that Kayla takes more than 6. More than 6 out of how many? So n is not given over here. So n is unknown. So how many number of tries she's going to take? So when n is not given, we know that this is a geometric distribution because a geometric distribution doesn't have any n number of trials, and the geometrical distribution is distributed with geo with only one parameter, which is as p. Now for any event that is greater than p, or greater than any number that's given, that's going to be x is greater than r, which is basically the property of failure to the power of r, q to the power of r. So in this case, we have property of x being greater than 6. So this is going to be, if p is this and we have q as 0.75, 1 minus p, that's going to give you q. So this is just going to be 0.75 to the power of 6. And we're going to get this as 0.1783 SF. That's your answer. Now, part B, it says find the property that for a random sample of 10 throws. See, now n is given in this part. So that's how we distinguish between a binomial distribution and a geometric distribution. Whenever the number of trials is not given to you, that's a geometric distribution. Because the normal distribution and a binomial distribution both have number of trials. So here it says find the property that for a random sample of 10 throws, so n is 10, Kayla achieves at least 3 successes. So at least 3 successes. So that's going to be x is greater than equal to 3, at least 3. At least 3 means 3, 4, 5, and goes all the way up till n is 10, till 10. So we have to work out the property for all of these, where the probability is given as 0.25 for success, like in part 1, and probability of failure will be 0.75. Now we know that this is a binomial distribution, so this has a formula of NCR P R Q n minus r. So since we have to work out the probability of find the probability for this, she achieves at least 3 successes. So that's going to be all the probabilities that are from 3 to 10. So it's not reasonable to work out all the properties from 3, 4, 5, and all the way up to 10. The easier way of doing this is you'll write this as probability of x is being greater than or equal to 3. It's the same as 1 minus the probability of getting x as less than or equal to 2, which is going to give us 1 minus the probability of 0 plus probability of 1 plus probability of 2. So if we add the probability of 0, 1, and 2 and subtract all of these 3 probabilities from 1, we will be getting the probability of getting 3 or more. So 1 minus, now the probability of 0 will be 0.75 to the power of 10. If you plug this in this formula, we are using this formula for all of these, for 0, 1, and 2. So probability of 1 will be 10C1. We have 0.25 and 0.75 to the power of 9 plus 10C2, 0.25 to the power of 2, and 0.75 to the power of 8. That's going to give us 1 minus all of these probabilities. That's 0.0 5631 plus 0.18771 plus 0.28156. And we should be getting 0.474. So that's question number 3 done.